Hello everyone. In this video, we will discuss about the regression modeling. So, a regression is a statistical method used in finance, investing, and other disciplines that attempts to determine the strength and character of the relationship between one dependent variable and independent variable. Now, I will explain in detail about regression with my handwritten notes. Regression. Regression analysis is a set of statistical processes for estimating the relationship between a dependent variable and one or more error-free independent variable. Dependent variables are often called as outcome or response variable, and independent variables often called as regressors or predictors. Regression analysis is used for two conceptually distinct purposes. It is widely used for prediction and forecasting, where its use has substantial overlap with the machine learning. And in some situations, regression analysis is also used to infer a causal relationship between the dependent and independent variables. Now, what is dependent variable? So, the dependent variable is the main factor in the regression which we want to predict or understand is called the dependent variable. It is also called the target variable. Independent variable. The factors which affect the dependent variable or which are used to predict the values of dependent variable are called independent variable and also known as the predictors. Now, what is outlier? Outlier is an observation which contains either very low value or very high value in comparison to other observed values. Now, multicollinearity. Multicollinearity. If independent variables are highly correlated with each other than other variables, then such condition is called multicollinearity. Some example of regression can be prediction of a rain using temperature and other factors, determining market trends, prediction of a road accidents due to rash driving. Now there are many types of regression like polynomial and multiple, but here we are discussing about the linear regression and logistic regression. So what is linear regression? It is a statistical regression method which is used for predictive analysis. It is one of the very simple and easy algorithms which works on regression and shows the relationship between continuous variables. It is used for solving the regression problem in machine learning. Linear regression shows the linear relationship between the independent variable that is on x-axis and dependent variable that is on y-axis, hence it is called as a linear regression. Now linear regression is of two types, simple and multiple. If there is only one input variable, then such linear regression is called simple linear regression. And if there is more than one input variables, then such linear regression is called multiple linear regression. Equation for simple linear regression is y equal to mx plus b plus e. X is equal to independent variable predictor, y is a dependent variable target, m is equal to slope, rate of change in y with respect to x, and b is intercept, that is value of y when x is equal to 0, and e is the error term. Multiple linear regression, y equal to m1 into x1 plus m2 into x2 and so on plus b. Here we have more than one input variables. Now this figure shows as the year of experience increases, salary also increases. Some applications of linear regression are analyzing trends and sales estimates, and second is salary forecasting. Now logistic regression. Logistic regression is another supervised learning algorithm which is used to solve the classification problems. In classification problems, we have dependent variables in a binary or discrete format, that means 0 or 1. And logistic regression works with categorical variables such as 0 or 1, yes or no, true or false, spam or not spam, etc. It is predictive analysis algorithm works on a concept of probability. Logistic regression used a sigmoid function or logistic function, which is a complex cost function. This sigmoid function is used to model the data in logistic regression. The function can be represented as fx equal to 1 upon 1 plus e to the power minus x, where fx is the output between 0 and 1 value and x is the input of a function. Now the application of the logistic regression are predicting disease presence and credit risk modeling. So this was about the regression. Now Now we will see the estimation model evaluation using Python of regression modeling. Now, in the first 5 line, we started by importing essential libraries. Pandas is for handling data. Train test split help us to split data into training and testing sets, and linear regression is the model we will use, and mean squared error and R2 square score will help us evaluate the model's performance. Now load the California housing data set. These lines are used to load the California housing data set using a fetch California housing setting as frame equal to true. Converts it into a pandas data frame, making it easier to work with. Now data.info, we will display a data information using a data.info. In data, the info method shows the details about the data set like the number of rows, columns and data types. This helps us understand the structure of our data before proceeding. Now we will split the data into features and target variable. We separate our data into X features and Y target. Here med house well is the target variable representing the medium house value. The feature X are other columns that we will use to predict the value. Now we will split the data into the training and test set. 80% of data will be in the training and 20% of data will be in the test set. Now fit a linear regression model. Now linear regression model is used to create an instance of a linear regression model and train it using the fit method that uses a training data. This is where the model learns the relationship between the features and the target variable. Now we will make a prediction on the test set by using the predict function, which takes the X test as a parameter. And once the model is trained, we use it to make a predictions on the test set. After the prediction, we will evaluate the model. For the evaluation, we have two metrics, root mean squared error and second is the R squared. So this measures how the predicted values deviate from the actual values, and lower the value of root mean squared error indicates the better performance. And the R2 means R squared indicates how well the model explains the variability of the target variable. A value closer to 1 means the model fits well. And after that, we will print the value of root mean squared error and R squared here. So this is the output of the following code, which contains the column value, non-null count and data type. Thank you for watching my video.